That's exactly what 1 radian is. It's the distance, if you go out this distance and then you go across that same distance, that's 1 radian. And then we said that there was how many radians in a full revolution? How many radians? 2 pi of them. It's weird shit, right? But in calculus, everything is tied to, I mean, a lot of what we do is tied to this circle, right? And so this measurement of a radian is kind of our what's the word I'm looking for? It's our standard measurement for angles, is radians. But when you're not doing calculus and you want to talk about like 45 degrees, like in some other setting, like physics or something, they like degrees there, right? But in math, it's just radians is the standard unit of measurement. I wish we just had radians or just degrees, one or the other. It's kind of like we have the metric system and the US system, right? It's like we have feet, but then we have meters. It'd be nice if we just all used the same thing. I wish that was the same way with angles. See, we couldn't agree on that. Okay, what about this one? What sine inverse of 3? What do you think about that? Maximus?
Yes.
Yes? Can you tell me in words what this is asking?
Looking for my brain went blank. Okay.
Just think about what we've been doing, right? This is asking
For the y value.
the y value on the unit circle, where the y value is 3.
Is it screaming at me kind of?
It's a kind of a trick question. Is it possible?
Is it undefined?
Yeah, exactly. This is not possible, right? This is saying where on the unit circle. Remember, the unit circle has a radius of 1, right? So where are you ever going to get a y coordinate to be 1? I mean, sorry, to be 3, right? It's not here, right? So this would be undefined. Sorry, I didn't mean to trick you there, but you did good. You did good, 'cause it should have seemed weird, right? Undefined. Okay, what about this then? What about inverse sine of 1/3? Inverse sine of 1/3. Well, Jared, I just happened to pick you here. Jared? Yep. So Jared, you've been following, yes? This is basically where's the y coordinate going to be 1/3, right, on the unit circle?
Yeah.
And that should be troubling everybody, right? Because that's not one of our common angles, is it? Like nowhere on our unit circle did we ever have 1/3 as our y coordinate, right? But it does exist, do you agree? Like it does, there should be somewhere on here, right here, somewhere on here, at some angle, right, I should have a y coordinate of 1/3 because this is 1 up here, right? My y coordinate up here is 1, and my y coordinate over here is 0. So somewhere between here and here, I should achieve 1/3 somewhere, right? Where though? It's not our common, right? So somewhere over here, I don't know what this angle is. The y coordinate is 1/3. Yes? Now, I'm not looking over here because it's an inverse sine, so I'm not even looking over here. Remember, there is another place over here where the y coordinate's 1/3 as well, but because we're talking about inverse sine, we're not allowed to look here. And then, well, of course, if it was negative 1/3, I'd be looking down here, wouldn't I? But it's positive 1/3. Okay, so we can't do this without a calculator. But we have calculators, right? So on your calculator, there should be a button there. I think my calculator's batteries are dead. It was acting weird yesterday. So yeah, I'm going to have to rely on you now. Shit. I'm screwed. No, it's okay. It's okay. I'd rather you do it. Okay, so look for the key. Somewhere on your calculators, you probably have to hit your second key first. What's that? Do you? You have an extra one? Okay. If you have an extra one, I'll take that.
Is the answer going to be a decimal?
It should be a decimal, okay? Well, I don't know. It depends. Okay? So find the key on your calculator. You might have to hit your second key first, but do that and put in either 1 divided by 3. Let me see. The answer I got...
Does it matter if they're in degree or radian?
Okay, yeah, exactly. So you're going to get one of two answers. You're either going to get 19.47, okay? And I am in degree mode on my calculator, all right? So I need to put right here 19.47 degrees. The other answer you could get was a decimal, right? What did you get for the decimal? 0.34. Approximately 0.34, 0.34. And this would be radians, right? Now, we don't normally write radians. I'm only going to write it just to make sure you understand that that's giving us our degree measurement. This is giving us our radian measurement. Remember, we could always convert from degrees to radians, radians to degrees? If I asked you to convert that to radians, you get this. Convert this to degrees, you get that, all right? So the mode you're in your calculator matters, right? This matters because if I want the answer in degrees, I'm going to need you to be in degree mode, right? How about this? What's the inverse sine of negative 0.25? Let's do it in both again. So 0.25 is not a common point on the unit circle again. So we're just going to go into our calculator. Negative 0.25. Where's my negative key here? There it is. Negative 14.48, something like that. Negative 14.48 degrees. And then that's in degrees and radians. Who's got my radians?
Negative 0.25.
Negative 0.25. Do y'all see that the calculator is smart enough to give us a negative angle that puts us down in that fourth quadrant? Y'all see that? Because this is really saying where on the unit circle is your y coordinate negative 0.25, right? That's what this is saying. So it knows to go here. It knows not to go all the way around. Right? Not allowed to look here. Making sense? Yes?
Would the calculator give you like an answer if you like did like sine inverse of like the shaded region? Like if you picked a point in the shaded region, would the calculator give you an answer? Or?
Well, you would have to pick a y coordinate over here,
Yeah.
right? So give me a y coordinate. If you give me a y coordinate over here somewhere, like right there, it's going to think you're right here. So it's going to give you that angle. If you give it a y coordinate like this y coordinate, it's going to think you're over here and give you that angle. Yeah? Yes?
So I'm noticing that it's like 0.34 radians. So it was on the calculator. It was probably 1/3. So are we just getting the radian?
Oh no! Oh, good recognition there. What's being noticed here is that this number 1/3 is pretty close to 0.34, right? And this number negative 0.25 is pretty close to this, right? That's what you're pointing out?
Yeah.
That's a good observation. That's actually a coincidence, all right? It turns out that the smaller the angle is, the smaller this number is, the closer it will be to this. In other words, sine x is approximately x for very small values of x. So if x is small, this is not part of this class, I talk about this in Cal 2. If x is small, then this is approximately true. So let's take something really small. What if I said, what's inverse sine? Okay, inverse sine of 0.01. Okay, if you do that in your calculator, your answer can be really close to 0.01. Is it? What do you get? In radian mode. Yeah, if you're in degree mode, it won't be as good. It's got to be in radian mode. 0.01? Something like that? Close to it? Yeah? The smaller this number is, the closer it is to being this exactly. And that is a very, man, I'm going to start talking about that in like 3 weeks in my Cal 2 class. We still have a long way to go. It turns out, I'm just going to show it to you right now, that sine x is actually this function. X minus x cubed over 3 factorial. Have you ever seen a factorial symbol before, an exclamation point after a number? What that means is 3 times 2 times 1. That's what that means. Plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. And this pattern goes forever. And this on the right-hand side is what's called the Maclaurin series for the sine function. And so when you type into your calculator, if you type right now into your calculator, what is sine of 1? If you're in radian mode, if you type that into your calculator has no idea what the sine function is. No idea. It only knows the sine function is this. So it replaces this with a 1, and then minus 1 cubed is 1 over 3 factorial is 3 times 2 times 1, that's 6, plus, and then 1 to the 5th power, and then 5 factorial is 120, then minus, and it keeps going, and whoever programmed the calculator will tell it to stop at some point, like maybe go out 30 terms and stop, and that's what it will return to you as your answer, all right? So, if x is really small, if x is tiny, then what happens if you take a small number and cube it? Does it get bigger or smaller? If you take a small number and cube it, it gets smaller. Small number to the 5th power gets even smaller. So if your x is small, these things become insignificant because they get so small, and that means it's basically that. And so sine x is approximately x whenever you have small values of x. And it turns out cosine of x is approximately 1 minus x squared over 2. But that's a different story. I'm going off, I'm sorry. That's a great question. I mean, because you noticed it, it seems like it is, right? It just, you know. All right, good. How about this? Let's do one more, just to prove to ourselves that isn't always the case. How about if we do inverse sine of 0.95? So that's saying where on my unit circle is my y coordinate 0.95, right? Where on the unit circle is my y coordinate 0.95? That's like really close to being up here, isn't it? The y coordinate here, 0.95. What are you getting for an answer in radians? Point what? 1.25? So equals 1.25. Do you see that they're pretty far away from each other now? See that these are pretty far away? I mean, it's like these were pretty close, like 1/3, 0.333, 0.34. Negative 0.25, negative 0.25. But once your angle gets a little bit big, that property goes away. Okay, how do you feel? Feel like you understand this? Yes? Okay, that's sine. Let's talk about cosine. What's that? You sound upset. What's wrong? No love for the cosine or what? All right, so let's talk about inverse cosine. Well, let's start with a picture of cosine. If we look at f of x is cosine of x, if we graph it, it looks like this. Right? That's our standard cosine curve. And then it goes backwards as well. So as it sits here, there's no inverse, right? Fails the horizontal line test. So we need to cut it somewhere, don't we? We need to cut it. And again, we had to agree where to cut it. This is pi, right? That's pi over 2. This is negative pi over 2. Right here. What I want to point out is that we can't do the same cut we just did for sine. We can't. Do y'all see that if we try and go between negative pi over 2 and pi over 2, we would get this? And what's wrong with this? Can somebody tell me what's wrong with this? Yeah, this would fail the horizontal line test, right? And not only that, it doesn't take on all the values. We need to cut it in a way that we get everything from -1 to +1. Everything in between. This not only fails the horizontal line test, it doesn't even get all the values from -1 to 1. So by looking at it, what looks to you to be a good place to cut it? 0 to pi. 0 to pi. Do y'all see that from 0 to pi, we get all the numbers in between? From -1 up to 1, we get everything. And from here to here, if I cut this off, and I cut off right here, straight down to the bottom. If I cut that off, do y'all see that we get all the values between -1 and 1, and it passes both the vertical and horizontal line test? Yes, that's what we agreed to, all right? So for f, if we'll say it this way, I'm going to do it the way I did with the other one. If f of x equals cosine x, and we restrict x between 0 and pi, then the inverse function is written cosine with a little -1 of x, or it's written arc cosine x. Arc cos of x. This is new notation, okay? We're going to play the exact same game we just played, all right? We're going to play the same game with one huge exception. Well, there's two exceptions. What are the two differences as we start to ask what, arc cosine of something is? What are two main differences?
It's the x value.
We're looking at the x value on the unit circle, and not the y, right? And where we're looking is different, right? We're not looking between pi over 2 and negative pi over 2 anymore. We're looking between 0 and pi, right? That's the big difference. So let's do some examples. What is arc cosine of 1? All right. I'm going to write in words what this is asking us. This is saying where on unit circle is the x coordinate equal to 1, right? Right? Where is the x coordinate equal to 1? But, what else? I can't be down there, right? I have to be between 0 degrees and pi. I'm only allowed in the first and second quadrants. So what's the answer? 0. 0 degrees or 0 radians? Same thing, right? 0 degrees and 0 radians are the same, right? That's the angle, right? The angle that you would go to, to get an x coordinate to be 1 would be out here, right? And so that angle is 0, not 2 pi, right? You can't say 2 pi because 2 pi would mean you go all the way around. So 0. How about another one? What about cosine inverse? Oh, hey, try this. On your calculator, do cosine inverse of 1 on your calculator. You should get 0, right? All right, how about this one? Cosine inverse of -√2/2. Ooh, you should recognize that -√2/2, right? That's a common point on our unit circle. So this is saying where on the unit circle is our, which coordinate? X coordinate, -√2/2, and we're only allowed in the top 2 quadrants. So, Jackie? How do you feel about it? You know where it is? Right there, right? Okay, so this is saying where not allowed here, right? So I think you're saying this, right? Okay, that's it. Do you know the angle? In degrees or radians? I don't care. Anything's better than nothing. 135. Okay, so this would be 135 degrees. All right? Okay, so make sure you put the degree symbol there. That is correct because that's where your x-coordinate is negative root 2 over 2. Now, in radians, what is it? What is it? 3 pi over 4. Yeah? Cosine inverse of 0. Gerardo? What do you got? Pi over 2. Pi over 2, right? Where on the unit circle is the x-coordinate 0? And you're not allowed down here, right? Off limits. So pi over 2. I think y'all are getting this. I think. Any questions? We'll do maybe one or two more. Cosine inverse of 0.72. Yeah, reach for the calculator. See, because you don't know where that is on the unit circle, right? So you're going to need the calculator for that. So you can imagine that on the next test, I'm probably going to give you a little portion again where you're going to have no calculator. And that's going to be me asking you questions like this, where you shouldn't need a calculator. You should be able to find your way on the unit circle, right? Same with this. Something like this, you're going to need a calculator. There's no other way around it, all right? We keep going. Yes? What do we get? What do we get? 43.94? 95 degrees. Close enough. And then in radians, what is it? 0.77? 0.77 radians. So if you don't put the unit, if you just put 0.77, it's understood to be radians. I think you'll get this. So I think I'm going to move on. Okay? How about we look at the inverse tangent function? This one's a little weird. The inverse tangent. Arctan inverse tangent. All right, so this is a weird one, all right, because if we graph tangent, tangent looks very different than sine and cosine, right? So if we let f of x be tangent x, I'm going to draw it over here, okay? I'll come back. I'm going to still need to do a domain restriction just like we did with sine and cosine, but I'm going to do it over here. We learned that to graph tangent, you have vertical asymptotes at pi over 2 and negative pi over 2, right? Remember that? And it goes up like this, and then here, and then the graph goes like this, right? And then it keeps repeating itself, doesn't it? Like it does the same thing over here, and then another vertical, and then the same thing over here, and then backwards it does the same thing. So when you look at that, does it pass the vertical line test? Vertical?
Yes.
Yes. Horizontal?
Yes.
See, I hit it here, here, here. So I would hit it in infinite number of places, right? So I still have an issue, right? Do y'all see that I have an issue? So I need to figure out where to cut it. So what makes sense where you could cut it to make sure that you get everything in there and you pass both the vertical and horizontal line test? Yeah, just between these two asymptotes, right? Like, let's just throw all this shit away, throw all that shit away, and just take that right there. This is a perfect function that passes both vertical and horizontal line test. By the way, the book mentions this, and you'll hear this later. This terminology, a one-to-one function. Have you all ever heard that? Like, what's a one-to-one function? A one-to-one function is a function that passes both the vertical and horizontal line test. Any function that passes both those tests is one-to-one. All right? So I think that's a pretty natural place to cut it, right? Right there? Okay, so if we do this, and we restrict, be careful here, we restrict x between negative pi over 2 and pi over 2. There's one big difference here. This is almost like the sine, right? This is the way we restricted sine. Isn't this what we did? But with sine, go back and look. I said it was okay to actually be equal to pi over 2 and negative pi over 2, didn't I? Here you can't. Because at pi over 2, tangent is undefined, right? And at negative pi over 2, tangent is undefined as well. So we cannot ever let it equal pi over 2 and negative pi over 2. So it's a slightly different domain restriction than sine. Slightly, right? All right, let's try some. These are a little harder. What's inverse tangent of 1? All right, let me talk through this. On the unit circle, tangent isn't the x-coordinate, right? That's cosine. Tangent's not the y-coordinate, that's sine, right? But tangent is the ratio of the y divided by the x, right? So where on the unit circle, no, what's wrong? You okay?
Yeah.
You sure? Okay, that looked like you didn't like that. No? So tangent is the y divided by x. So where on the unit circle, and we're not allowed over here anymore, right? Only between pi over 2 and negative pi over 2. Where is the ratio of the y-coordinate divided by the x-coordinate equal to 1? 45 degrees, right? Right here. Right there. That's root 2 over 2, root 2 over 2. And so if you take the y and divide by x, you get 1. Question?
Yes, just to be clear. So it's going to have the same restrictions as a sine, where we can get our
Yes, with the exception that you'll never get pi over 2 to come out as an answer. Like, you'll never plug anything into this and get pi over 2 or negative pi over 2 because you have to cut those endpoints off because this function's not defined at those endpoints. So what's the answer here? 45 or degrees or pi over 4. Okay, so try this then. What's inverse tangent of negative 1? So where's the ratio of the y-coordinate divided by the x-coordinate equal to negative 1 instead of positive 1? Yeah, so we're down here now, right? It's here, this one. This is root 2 over 2, negative root 2 over 2. And so if you take this and divide it by that, you get negative 1, right? But be careful, right? You can't go all the way around. Don't tell me 7 pi over 4, right? Don't tell me 315 degrees. You're not allowed to go all the way around that way, right? You can only go backwards to here. So backwards would mean negative pi over 4. Or negative 45 degrees, right? Let's do some more of these that are a little harder, but once we do them, you'll hopefully recognize them from here on out. Inverse tangent of root 3. Believe it or not, that is a common point on the unit circle. You just have to think about, well, can you tell me what quadrant I'm going to have to be in? I have to be in the first quadrant, right? Because this is saying that when we take the y-coordinate and divide by the x coordinate, we need to get root 3, right? That's basically what that's saying. Where on this unit circle, when you take the y coordinate, divide by x, you get root 3. Well, you know it's going to be a positive answer, right? The only way this can be positive is if these are both positive or if these are both negative. But if these are both negative, what quadrant are we in? 3, right? We're over here. If y and x are both negative, then we're to the left and down. Not allowed to be over there, right? So we have to be in the first quadrant. So someone said an answer. What was it? 60 degrees? Pi over 3 right here. So let's take a look at that. This is 1/2. This is root 3 over 2, right? Take the y coordinate, root 3 over 2. Divide it by the x coordinate, 1/2. And then you flip, right? And this becomes root 3 over 2 times 2 over 1. And the 2's cancel, you get root 3. So, these I think are a little bit easier for us to comprehend, process, right? That the x and y coordinates kind of have to be the same. This is just, root 3 is just one of those ones you're just going to need to remember does occur at one of your common angles, right? So the answer was what? Pi over 3, or in degrees, 60 degrees. Let's do another one. How about inverse tangent of, this is the one they like to do. What is it? Root 3 over 3. Let's make it negative. Root 3. Negative pi over 6. Or negative, wait, is it pi over 6? Yes? Let's convince ourselves. All right, so we're not in these quadrants because we're talking about inverse tangent, right? We have to be in the fourth quadrant, and it needs to be at either this one or at this one. Why is it not at the middle one? That's going to give us -1, right? So it's either here or here. So this one has root 3 over 2, -1/2. That's the coordinate there. And this one is 1/2 and root 3 over 2, but this one's negative, right? So what if I did this divided by this, right? The y divided by the x. Wouldn't I get the same answer as I had over here, but negative? I'd get negative root 3 over 3, right? If I did this one. But what about that one? Take the y coordinate and divide it by the x. So the y coordinate divided by the x would be -1/2 over root 3 over 2. That's -1/2, right? Keep it, flip this one up, 2 over root 3. The 2's cancel. You get -1 over root 3. And then what did I do over there? Yeah, I rationalize, which I told you I don't like to rationalize. I'm giving you this because a lot of textbooks will give you this problem.